Some points on Venus are in the dark
for a long time.
for 60 days, and you would expect them to cool off, but they don't.
That's so interesting because
Which is amazing.
when you're measuring Venus, you're measuring the side away from the sun, right?
Well, no, it depends on where it is in its orbit.
When it's close to the Earth,
Oh,
yes.
right.
When
If
it's
it's on
close-
the other side of the
Yeah.
sun, you can. I
Yeah,
see.
and that was one of the measurements I made, which was the toughest thing I ever did, because if you wanted to find out what temperature was on the sunlit side,
Yeah.
you have to observe it when it's on the other side of the sun.
Right, which it's a lot further
So
away.
it's
for
way
starters.
further away, so the radio emission that you capture is much less. And so you have to observe for hours to get measured with an accuracy that tells you everything's happening.
There you go.
For hours. That's
But
what
you're
it-
saying that the temperature of the planet didn't change depending on
It
whether
don't-
it was
doesn't
facing the
change.
sun or not?
Yeah,
How do
that-
you explain that?
the
That doesn't make
atmosphere-
sense.
I
the
know.
Earth doesn't change that much.
But
Is it that the sun heats up the atmosphere and the atmosphere just keeps the temperature no matter where it is?
Well, on Venus, yeah. On the Earth, not so much. But on Venus, yes, because the Venus atmosphere is 100 times the atmosphere of the Earth. And pressure, which means the total amount of gas,
Yeah.
is 100 times more.
But what's the
So-
atmosphere made out of?
And Venus, it's carbon dioxide.
Oh, it's carbon dioxide.
So, I mean, here, on a clear night,
Yeah.
it gets very cold.
Yeah.
But if there's a lot of clouds,
That's
it
a
doesn't
good
get
point.
so
It-
cold.
that's a
So
really
on
good
Venus,
point.
it's clouds all the time. But Frank's measurement was the first indication of the so-called greenhouse effect on Venus, something which I think NASA rediscovered a few years later and takes most of the credit.
Well, they didn't trust the radio astronomers.
What's
they,
the-
didn't-
yeah.
they weren't sure
Yeah.
that this really worked.
Yeah.
How long does it take Venus to go around the sun? What's its?
200 days, I think,
So it's
to go around this.
200
No,
days.
no, it wouldn't be that. It's less than the moon. It's about 100 days.
So that's really interesting. So it revolves. It takes it longer to revolve than it does to go around the sun, right?
Yeah, yeah.
That's really interesting. Huh. What causes? I have so many questions. What causes a satellite to be locked? What do you call it?
Tidal.
Tidal lock. What makes the moon? tidal lock?
Tides do it.
The tides on Earth do it.
The tides on the Earth are slowly, as the object goes around whatever it's going around.
Yeah.
In the case of the Earth, it's the Earth. The tide pulls on the fluids, the oceans, and it tries to pull them in the direction of to the sun, because that's the way the tidal vector points. And so, in the case of our moon,
Yeah.
as it did that over history, over billions of years, it just brought the moon to a stop. So it stopped.
It stopped rotating.
Well, it's rotating once every orbit. It's always keeping
It's
one
a-
face to the Earth,
Yeah.
because one face will be attracted more by the mountains and things on the object than any other place. So it eventually ends up with that
So
one
if-
area pointing towards the Earth.
So if the moon had no mountains, if it were a perfect sphere, it wouldn't get tidally locked, right?
It wouldn't get
wouldn't.
close to tidally locked.
wouldn't,
It would be slowed
And-
down, because the force slowing it down is there no matter how round or.
And if the Earth had no oceans, you wouldn't have tidal locking, right? So,
Yeah, because
You get some of that from the solid Earth.
but there are
The,
planets.
the
that-
solid Earth has tides.
yeah, there's
the what?
This-
Oh, you mean
tides.
the continents?
Yes.
Yes, they get pulled on too, and they move up and down about a foot actually.
Yeah.
They're tides in the Earth.
And we can measure that now with VLBI.
Really?
Yeah. And
So-
it goes further than that. In order to interpret the VLBI astronomy data, we build into the reduction program the known effect of the Earth tides, the fact that they,
Is that right?
yeah, that's cool. And general relativity.
Of course.
At the beginning, we used to try to measure the general relativity effect. Now we actually have to correct all observations for effect of general relativity.
Like the GPS system has to be corrected for that, right?
Yeah.
Um, I see. So that's why there are tidally locked satellites around other planets that don't have oceans.
Yeah.
It's that
Jupiter, all the satellites are tidally locked too.
Ah, that's really interesting. A retroactive Nobel Prize.
I also
That's what they should do.
That's what they should do.
observed Mercury,
Uh-huh.
but that was so difficult here that the observation really wasn't much use because there was too much contamination by sunlight.
Because it's so close.
Yeah, Mercury's always close to the sun.
So you were trying to measure its temperature, or just is that what that was about?
Measure it just as we've done with Venus.
I see. Did you get any measurements? I mean, do you have or was it just completely corrupted?
Yes, we detected the planet, but
I
not
see.
with an accuracy that would made it something that was scientifically important.
Yeah.
The other big one was Jupiter.
Uh-huh.
We detected the radiation belts of Jupiter with this dish early on. That was about the second thing that was.
And these are belts in the atmosphere of Jupiter,
Well, they extend way beyond the atmosphere.
way beyond the atmosphere.
Yeah, and those have.
Are they like the ones I know? The Earth has them.
Yeah.
One's called the Van Allen belt.
The Van Allen belts, but on Jupiter they're very much larger and many more particles.
Uh-huh.
They're really big deal.
Uh-huh.
And of course they rotate with the planet.
Uh-huh.
So we measure the rotation. We measured the rotation of period of Jupiter to a few seconds,
Uh-huh.
which is really just a curiosity. It doesn't really make much difference, but that's a thing we did, and we were able to show that the outer parts of Jupiter do not rotate at the same
Really?
speed as the interior.
Is the interior solid? Does it have a solid interior or not?
It's got some solid layers, but the middle part is molten.
Molten.
Yeah,
I see. So it does have a core.
it's got a core, and it rotates.
Do we know how big the core is?
Yeah, we know. All that
How big is
stuff.
that
I don't-
compared to the
I
rest
don't
of the planet?
remember.
Oh,
Anybody know?
I don't remember. Are you talking about Jupiter?
yeah.
I don't know, but I think isn't there still some possibility that the core is
I thought the core was
metallic hydrogen?
Yeah.
Yeah.
Okay,
Which
what
is
is
really
metallic hydrogen? Explain that.
Ultra high pressure hydrogen. So it turns into like it turns into
Solid.
basically metal. Yeah.
Can you do that on Earth? Can we do it here, or do we not?
I don't think so.
It's not possible.
It requires a pressure we can't achieve.
Yeah, liquid hydrogen.
Does it actually solidify?
I guess.
Yeah, I don't know how that works.
I thought they called it liquid metallic.
Yeah, I thought that was like that. I thought it was like a weird like.
So that's what they think the core of Jupiter might be. Is that the same for Saturn? For all the gas planets?
Saturn, I think they said the core is a little bit different. It's probably not liquid metallic hydrogen, but it's very compressed and things are dissolving into it and out of it.
One thing that's really cool about Saturn is that it's incredibly low density. It would float. If there was like a big tub of water, Saturn would float.
Astronomers use the term metal rather loosely. Hydrogen is a metal.
Hydrogen's a metal?
Yes.
Even they even call it a metal when it's in gas.
It's the only one that's not a metal.
It's everything else.
Everything else.
It's like hydrogen, yeah.
But the magnetic field is locked to the core. So if you measure the rotation rate of the magnetic field, you get the rotation rate of the planet. And you can't measure that on the surface because on the surface there's high winds and the whole atmosphere is moving around Jupiter at a speed of about 200 miles an hour.
So is there something about the solar system that produces the solid planets inside and the gaseous planets further out? And is that true in all planetary systems we found?
Yeah.
The gaseous,
Not in the new exoplanets. That's actually one of the really surprising things is they're not like ours.
they're not like that. That's what I was going to ask. They're not. Huh?
It just depends on.
So is
how
ours
warm-
just happenstance? I mean, is it?
Yeah, it depends. When you're in, when the part of the planet is in close to the star heats the atmosphere and a lot of it evaporates. So you end up with a solid object with an atmosphere.
I see.
If you're far enough out, that great, huge atmosphere just is there all the time. It changes everything.
Yeah.
Here comes the bus.